In this session, we are going to cover the topic of transactions. What is a transaction? Whenever you do an operation, like for example on an ATM that you want to dispense some money, we are doing a transaction. When you go to the bank and deposit some money, that's also a transaction. When you transfer from one account to another account, that also is an example of a transaction. Transactions in databases have used to do operations. Um, when we have a transaction, we have some activities that are executed during the transaction. For example, if we want to get some money from the ATM, we want to first read the balance from the account, and if the balance is bigger than the quantity, then we can get the money from the bank. And the problem is when we have a crash in the system, we already changed the balance, but we haven't dispensed the money. So if we have an error in the middle of the execution, then we have to go back and um, put the balance in the original amount. So for that, we need to work with the transactions. What is a transaction? A transaction is a program in like the one we already covered. This is a transaction. It's a sequence of operations. And this program retrieves data or updates information on the database. We have here that we are reading the balance and then we update the balance. So this is a write operation on the database. The program is considered an atomic unit. That means that you have to execute all the operations or none of the operations. The consistency is guaranteed by the transaction manager. Let's see an example. In this transaction, we are going to transfer money from one account to another account. So we are going to subtract a quantity from one account, and we are going to add the same amount to the other account. So we start the transaction and we assume that the database is in a consistent state before you execute the transaction. Once you start executing the transaction, you change the account one, and then at that moment you already subtracted the amount for the balance. In this moment, the database is inconsistent because the money it's somewhere, it's on the air, it's not on any of the two accounts. But if you continue the execution, you change the balance on the account 2 and you add the quantity. And then you finish the transaction by doing a commit operation. And you end the transaction and the database in a consistent state. So it is important that when we are executing transaction, we start from a consistent state and we move to another consistent state. In the meanwhile, you're going to have inconsistency. That's why we have to execute all the operations together. So we introduce some concepts here. When you start a transaction, you have to start with a begin transaction. And when you finish the transaction, you have to finish with a commit when you don't have any errors. So let's see what are the states of a transaction. When we begin the transaction, we are in an active state. Every time when we do a read operation or a write operation, we stay on the active state. When we finish the transaction, by the end transactions, we go to a commit state, partially commit state. And if we have an error here, we are going to go to abort the transaction and move to the fail. Or when you are doing the transaction in active state and you abort the transaction, you are going to be on a fail state. If there are no errors and you partially commit the transaction, you move to the commit state and then you finish the transaction. So we're going to start seeing the begin transaction and the commits when everything is okay, or the abort or rollback when there is a failure. When you have transactions, we have some properties of a reliable transaction. We call the acid properties. Acid is not because we're going to pour some acid into your program, but these are the initials of some properties. The properties are atomicity, consistency, isolation, and durability. Atomicity. Atomicity means that we must guarantee that all transactions are atomic. That means that we are going to execute every statement of the program, making sure that not partially completed transactions have effect on data. So we're going to execute the whole program or nothing. So here is our example of the catch out. So we read the quantity that the user wants, and if the balance is bigger than the quantity, we subtract the balance, and then we deliver the money. But let's assume that a foul occurs here. So if a foul occurs in the middle of transactions, you have to go back and undo whatever you did. So the quantity has to be subtracted again, and we do that, we roll back. So either we execute the whole transaction to the last minute, or we don't execute anything. So atomicity means all operations or none of the operations. Consistency. When you have the database in a consistent state, before the execution of the transaction and after the transaction was committed. So let's see an example. This is an example of two transactions running in parallel. So what we're going to do is we're going to switch from one transaction to the other transaction over the time, and we're going to see what happened. Let's assume that we have balance of $1,000. Okay, so when you start the transaction here and you want to get 100 here and 100 here, so at the end of the two transactions, you should have 800 in your account. Let's see what happens. So you start reading, executing this transaction, and you read the balance. In the balance, you read that the balance was 1,000. And then this transaction also reads the same value, 1,000. And it is enough money to get the $100 here. So you continue the execution, and at the same time, you continue the execution of the other transaction. Then we have balance equals to balance minus quantity. So it's 1,000 minus 100 is 900. Okay? And later you move to the other transaction. But the other transaction also have the 1,000, and also the balance will be 900. And here you dispense the money, and you dispense the money, and you do a commit, and you do a commit. So at the end, your balance is 900, which was the last change that this transaction did. And that is incorrect because you lost this transaction. The final balance should have been done 800, and it is 900. So now the database is not in a consistent state. So we need to make sure that that doesn't happen. Okay, isolation. Isolation means that concurrent transactions, they must be executed and generate the same result than serial transactions. That means that you have transaction 1 and transaction 2, and the transactions running sequentially will get some results. And if you execute the two transactions in parallel, if one transaction changes the value on a variable, the other transactions cannot read the changes that are done in the transaction. We assume that the transactions are independent. So here is an example. Okay, so what is the initial balance in the account if the initial balance is 100 and the amount 1 is 100 and amount 2 is 50? So if we have two transactions, so the final value will be 350 if the two transactions are executed okay, or it will be if this transaction is aborted, so the result will be 500 minus 50, 450. So let's see what happens. So you start this transaction and you read the balance. The balance is 500. And when you read 500, it is enough money to subtract $100 from the 500. So we change the value here. The balance is going to be 500 minus 100. It will be 400. Okay, and this transaction will read 400. Okay, but later you go back to this transaction and this transaction is aborted and go back to the previous state, and now the balance should be 500. But this transaction 2 already read the value, and it read 400. So you read data that is not valid anymore. So we call that garbage. So this transaction will have wrong data and inconsistent data because it read something that is not valid anymore. So in order to achieve isolation, this transaction has to wait until the other transaction commits or aborts. The other property is the durability. Durability means that all changes by committed transactions become permanent in the database and should not be affected as a result of the subsequent failures. If we have a failure and you already wrote something on the storage, it should have the same value in case of any failure. What are the possible failures? Permanent irrecoverable failure of durable media containing data on the database or recovery logs. If we have a system crash that requires initialization of the system, that also is a possible failure, or total or partial memory failure. So for these kind of failures, to operate in the database management system must be able to recover in case of some of these failures happen. So in summary, I presented here the definition of a transaction like a set of operations that you can execute, all or nothing property, and we have in a transaction a begin transaction. If the transaction completed correctly, we said the transaction committed. If the transaction did not finish completely and we found error, then we execute the rollback. And we cover the ACID properties, which are atomicity, consistency, isolation, and durability. Atomicity is all or nothing. Consistency is having the correct data in your database. Isolation means that a transaction cannot see partial results of another transactions. And durability, that means that your data is not lost, even in the case of a failure.